The goal of today's lesson is for students to understand that an algebraic equation is a statement of equality and that it's either true or false when values are substituted in for the variables. So we want to know what makes an equation true or false. So if we look through the following numerical statements, okay, and algebraic statements, we can determine whether they're true or false. And I'll just indicate with a T or an F. A statement is true under our laws of exponents. When multiplying, you add. This statement is false because it's addition. It doesn't use one of our laws of exponents, so you have to evaluate each one of these separately. You cannot combine the exponents and shortcut it. Next one is true. It's just demonstrating the distributive property. The next one is also true. It's the distributive property when dealing with exponents, since it's multiplication. The next one is false because, again, when you add or subtract and you're dealing with exponents, the addition or subtraction has to come first, otherwise it violates the order of operations. Next one is obviously a false statement. One has a +3, the other has a +4. Next one is true, using the distributive property. And the final one, we're not sure, because we don't know what x is. So we can't determine whether it is true or not. So, a couple of definitions. A number sentence is a statement of equality between two numerical expressions that is either true or false. Okay, that was like most of the examples in the do now, where all we had were numbers. An algebraic equation is a statement of equality between two expressions which can be either numbers and or variables. Again, we don't really get hung up on definitions as if this was an ELA class, but we want you to be at least aware of what we're talking about when we use these terms. So, identities. An identity is a situation where an equation is true for all real numbers. And we use the symbol R, capital R, with a line through it. Sorry, it doesn't look the greatest, but that's the symbol for all real numbers. Then, and I should put up here, if an equation is true for all real numbers R, then it is an identity. So, you actually saw this above, but a very simple example is 4x plus 2x is equal to 6x. It's an equation, y, it has an equal sign, and since this simplifies, because they're like terms, to 6x, we're saying 6x equals 6x. All this simply says is that no matter what value I put in for x, I will always get a true statement. So there's an infinite number of solutions. Let's contrast that with equations with a solution set that are not identities. So if an equation is true only for some values, so therefore there's a finite number of solutions, then it has a solution, but is not an identity. So, for example, taking what we just had over here, if I change this simply to 4x plus 2x equals 6, I now have an equation that has a solution, the solution being 1, and that is the only real number that will make that statement true. And then the third situation is equations with no solutions. So if no possible solution exists, meaning no numerical value can make the equation true. So again, if I had the statement x plus 1 equals x, you should be able to see that it does not matter what value I can choose for x. In our real number system, there is no value for x that will make that statement true. So infinite number of solutions, that's an identity. A set or finite number of solutions, that's an equation that is not an identity. And then if there's no solution, that's, again, an equation that has no value that makes it true. So if we take a look at our examples here, x squared plus 4x equals x parentheses x plus 4, we're going to fill in either I for identity, S for a solution, or NS for no solution. This is an identity because of the distributive property. If I were to distribute the x, you can see that I get the same expression on both sides of the equal sign. In the second one, I have a solution, and as you should probably be familiar with, if you looked at some of the earlier videos, not earlier videos, actually later videos, but I produced them earlier, I have two solutions to this, solving it with dots, and my solutions are 2 and negative 2. Looking at 11, there is no solution because there is no number squared is equal to a negative. Now, I said number, but technically it means no real number, because when you get to Algebra 2, there is a non-real number that satisfies that. But if you think about the definition of squaring something, it means to multiply something by itself. I can't multiply something by itself and get a negative. X cubed equals 27. Yes, there is a solution. The solution is 3. No, I want to write S again. Excuse me. Because 3 cubed is equal to 27. X cubed equals negative 27. Yes, there still is a solution. The solution is negative 3. Negative 3 times negative 3, 9. 9 times negative 3, negative 27. The next one, an identity. Why is it an identity? Because all I did was switch the order. So the commutative property tells me it's an identity. And then finally, the absolute value of x plus 2 equals negative 3. No solution. There's no, since this number would have to be a negative 5 to complete this, because you would get the absolute value of x equals negative 5. Well, no absolute value equals a negative, so there is no solution. Absolute values are not negative. So, to conclude, the purpose of today's lesson was to just demonstrate that when we are solving equations, we have three possible categories of solutions. The first category is it's an identity, which means all real numbers make it true. The second is there's a finite number of solutions. The third, there is no possible solution.